So in terms of conjugate, you are only changing the sign of the imaginary part of a complex number. So modulus of z means it is 1 square plus minus 1 square root, which is equal to root 2. So this is the value of the complex number. Here z bar represents the conjugate of a complex number and mod z is nothing but the modulus of a complex number. Hello everyone, a warm welcome to one and all. This is Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In today's session, we will be discussing about the modulus of a complex number, conjugate of a complex number and multiplicative inverse of a complex number. So we have already known what do you mean by the multiplicative inverse of a complex number. So that is we usually denote it by Z inverse. So we will be solving and recognizing what is the modulus, conjugate and multiplicative inverse of a complex number in this session. So modulus of a complex number. Modulus of a complex number, if Z is equal to A plus IB, then square root of A square plus B square gives you the modulus of a complex number. So that is we usually denote it by mod Z. So the symbol modulus Z is usually denoted here and its value is given by square root of A square plus B square. Suppose you have any complex number, for example 1 minus I. What is the value of A here? A is also 1, B is minus 1 there. So modulus of Z means it is 1 square plus minus 1 square root, which is equal to root 2. So this is the value of the complex number. Conjugate of a complex number is nothing but changing the sign of the imaginary part. So and it is denoted by Z conjugate, so or Z bar we can say. So it is usually written in terms of A minus IB. For example, suppose you have 3 plus 4i, its conjugate is 3 minus 4i. If this is Z, then this is Z bar. And if you have minus I as a conjugate, then its conjugate is plus I. If you have 3, that is only the real part, then it is only 3. Conjugate is also same, Z is also same. So in terms of conjugate, you are only changing the sign of the imaginary part of a complex number. Here we have few questions. Write down the modulus of I, 3 plus root 3. Let us see the first question here, I. So this is nothing but 0 plus 1 into I. So let this is equal to Z, then mod Z is A value is 0, 0 square plus 1 square, which is nothing but 1. So modulus of the first function is 1. Let us look at the second function. Mod Z is A square plus B square under the square root. So it is square root of 3 square. Here you have root of minus 3. So this can be written as 3 plus I root 3. Because I is nothing but root of minus 1. Root of minus 1 into root 3 becomes root of minus 3 only. So therefore it is root 3 square. So now it is 9 plus 3, which is root 12. So root 12 can be written as 4 3s are, which is can be written as 2 root 3. So 2 root 3 is the modulus of the given complex number. Next we have find the multiplicative inverse of the following complex number. To find the multiplicative inverse of a complex number, we have a formula that is Z inverse is equal to Z bar divided by mod Z square. Here Z bar represents the conjugate of a complex number and mod Z is nothing but the modulus of a complex number. Now let's see what is Z bar. So Z bar, as I said, conjugate is nothing but you are changing the sign of only the complex part. So this is if 2 minus 3i is Z, then conjugate is 2 plus 3i. Modulus of Z is usually mod Z is equal to square root of A square plus B square. If you square on both sides, it is mod Z square is equal to A square plus B square. So this is mod Z square. So here mod Z square can be taken as A square plus B square. What is the value of A here? 2 square. And what is the value of B here? Minus 3 square. So therefore it is 2 plus 3i divided by 2 square is 4, 3 square is 9, 9 plus 4 is 13. So you can write this as 2 by 13 plus I into 3 by 13 or 3 by 13i. So this is the multiplicative inverse of the given complex number. Next we have minus I here. So minus I means z is equal to 0 minus I. Value of A is 0, value of B is minus 1. So z inverse is nothing but conjugate divided by modulus of z square. Conjugate of minus I is plus I and mod z square is square root of 0 square plus minus 1 whole square, which is nothing but I divided by 1. So therefore I is the multiplicative inverse of minus I. Next we have find the conjugate of the following complex number here: 3 minus 2i, 2 plus 3i, 1 over 1 plus 2i, 2 minus I. So first multiply the given equation here. If you multiply 3 2s are 6, 3 3s are 9i. Next minus 4i minus 6i square whole divided by, here it is 1 2s are 2. Next minus I. Next 4i. Next we have minus 2i square. We know the value of I square is equal to minus 1. Substitute here. 6 plus 9i minus 4i is 5i plus 6 divided by 2 minus I plus 4i is plus 3i plus 2. So this is equal to 12 plus 5i divided by 4 plus 3i. Now let us take the conjugate and rationalize the denominator here. So if you take the conjugate here, it is 4 minus 3i divided by 4 minus 3i. To remove the irrationality of the denominator. So here 12 4s are 48 minus 36i. Next plus 20i minus 15i square whole divided by, this can be written as 4 square minus 3i whole square. And next here you will get this as 48 and this is I square is minus I, again minus 1. So if you substitute, this is equal to 48 minus 36 plus 20 is minus 16i. Next this is plus 15 whole divided by 4 square is 16, 3 square is 9, I square is minus 1. So minus of minus 9 is plus 9. And 48 plus 15, you will get it as 63 minus 16i divided by 25. So therefore here you can write z is equal to 63 divided by 25 minus 16 by 25i. So if this is your z, first we have to find z here, then we have to find the conjugate. What is the conjugate? Then z bar is the positive of this, that is 63 by 25 plus 16 by 25i. So this is the conjugate of the given complex number. Next we have, if x plus iy is equal to a plus ib divided by a minus ib, prove that x square plus y square is equal to I. We know x plus iy is a plus ib divided by a minus ib. If I change this as x minus iy, then here the numerator becomes a minus ib and denominator becomes a plus ib. Now multiply these two, x plus iy into x minus iy. Then you should multiply the RHS term a plus ib divided by a minus ib into a minus ib divided by a plus ib. Now this is in the form of a plus ib, a minus ib, which can be written as a square minus b square. So this becomes x square minus iy whole square. Here you can see the terms cancels and it is 1. So here I square is nothing but 1. So if you replace I square as, that is I square as minus 1, then you have minus of minus y whole square, which is plus y square, and here the value is 1. Hence the equation is proved. Next, consider the equation x minus iy as root a minus b by c minus id, and we have to show that x square plus y square whole square is a square plus b square divided by c square plus d square. Now let us see what is x plus iy here. So here if you replace x plus iy, then it is root of a plus ib divided by c plus id. So now multiply these two here. So here it becomes x minus iy into x plus iy is equal to root of a minus ib divided by c minus id into root of a plus ib divided by c plus id. Multiply these two. We have already known x minus iy, x plus iy can be written as x square plus y square. And here this is square root of, you can multiply because both are square root. A minus ib, a plus ib can be written as a square plus b square, which is of the same form. Again c minus id, c plus id can be written as c square plus d square. Now squaring on both sides. So if you square on both sides, this will become x square plus y square whole square. And here square roots get cancels, which is a square plus b square divided by c square plus d square. So this is the solution or the required equation. Next question. If 1 plus I divided by 1 minus I whole power m is equal to 1, then find the least positive integral value of m. So let us see first rationalize 1 plus I by 1 minus I. So here 1 plus I divided by 1 minus I into 1 minus I divided by 1 plus I. The conjugate, 1 minus I conjugate is 1 plus I. So to the power whole power m is equal to 1. First conjugate this. This becomes 1 square plus I square plus 2y. Here 1 minus I, 1 plus I can be written as 1 square minus I square. We know the value of I square is minus 1. So here whole power m is equal to 1. So 1 minus 1. I square is minus 1 plus 2y divided by 1 I square is minus 1 plus 1. Whole power m is equal to 1. Plus 1 minus 1 cancel. 2y divided by 2 whole to the power m is equal to 1. 2 get cancels. We got I power m is equal to 1. Now for what values of m we get I as 1? We have already learnt in powers of I. So when m is the product of the multiples of 4, we can say I value is 1. But we have to find the least positive integral. So the least positive integral where I can get the value 1 is 4. So therefore m is equal to 4 is the answer. In today's session, we have discussed the modulus of a complex number, how to write the multiplicative inverse of a complex number and its conjugate, and simple problems. Whatever the problems we have solved today, they may ask you for 2 or 3 marks question, a very important questions compared to your examinations. We'll continue few more concepts of complex number in our next session. Until then, keep watching, keep learning and keep exploring. Thank you.